Dear students, in this session, I would like to share the topic liquefaction of gases. In this liquefaction of gases, I would like to explain porous plug experiment with relevant theory. Let us see the liquefaction of gases. A gas goes into liquid and solid forms as the temperature is reduced. Thus, the processes of liquefaction of gases and solidification of liquids are involved in the production of low temperatures. Andrews' experiment showed that if a gas is to be liquefied by merely applying pressure on it, it has to be cooled below its critical temperature. Since the critical temperature of carbon dioxide and sulfur dioxide and ammonia are higher than room temperature, these gases can be liquefied at room temperature without pre-cooking simply by increasing the pressure. Joule-Thomson experiment is a very important technique to liquefy gases. The cooling produced depends on the difference of pressure on the two sides of the porous plug and the initial temperature. This is about the basic things regarding liquefaction of gases. Let us look at Joule-Thomson effect. Joule-Thomson effect. The statement is like this: if a gas initially at constant high pressure is allowed to suffer throttle expansion through the porous plug of silk, wool or cotton wool having a number of fine pores to a region of constant low pressure adiabatically, a change in temperature of gas, either cooling or heating, is observed. This effect is called Joule-Thomson or Joule-Kelvin effect. Let us see the porous plug experiment. See here, this one is the experimental setup of porous plug. Here the physicist Joule and Thompson, both, they are devised a very sensitive technique known as porous plug experiment. The experiment setup of porous plug is to study the Joule-Thomson effect as shown here. Here it consisting of a porous plug having two perforated brass disc D and D shown here. Here D and D are the perforated brass discs. The space between D and D is placed with cotton wool or silk fibers. The porous plug is fitted in a cylindrical box wood which is surrounded by a vessel containing cotton wool. This is to avoid loss or gain of heat from the surroundings. Totally, this cotton wool avoids the loss or gain of heat from the surroundings. T1 and T2. T1 and T2 are two sensitive platinum resistance thermometers, and they are used to measure the temperatures of the incoming gas and outgoing gas. Here T1 is a thermometer, platinum resistance thermometer, which is used to measure the temperature of the incoming gas, and T2 is another thermometer which is used to measure the temperature of outgoing gas. The gas is compressed to high pressure with the help of piston P shown here, and it is placed through a spiral tube immersed in water bath maintained at a constant temperature. If there is any heating of the gas due to compression, this heat is absorbed by the circulating water in the water bath. Let us see the experimental procedure, how it works. See here, the experimental gas is compressed by the pump P and is passed slowly and uniformly through the porous plug, keeping the high pressure constant, which is read by pressure gauge. Here pressure gauge is connected between these two, lower end of this one cylindrical vessel and the spiral tube. During the passage through the porous plug, here it is shown in arrow mark, the gas is throttled. This separation between the molecules increases. On passing through the porous plug, the volume of the gas increases against the atmospheric pressure. As there is no loss or gain of heat during the whole process, the expansion of the gas takes place adiabatically. The initial and final temperature of the gas are noted by platinum resistance thermometers T1 and T2. This is about the experimental procedure. Here in this slide, we shall discuss about the experimental results. A simple arrangement of porous plug experiment, which is already seen in the previous slide. The behavior of large number of gases was studied at various inlet temperatures of the gas, and the results are discussed as below. At sufficiently low temperatures, all gases show a cooling effect. At ordinary temperatures, all gases except hydrogen and helium show cooling effect, because hydrogen and helium shows heating effect. The third one, the fall in temperature is directly proportional to the difference in pressure on the two sides of porous plug. Fourth one is the fall in temperature for a given difference with rise in the initial temperature of the gas. It was found that the cooling effect decreased with the increase of initial temperature and becomes zero at a certain temperature, and at a high temperature the temperature instead of cooling, heating was observed. That means at a temperature higher than the temperature, instead of cooling, heating was observed. This particular temperature at which the Joule-Thomson effect changes its sign is called temperature of inversion. These are all the experimental results about porous plug experiment. Let us see the theory of porous plug experiment. Dear students, this is about the porous plug experimental setup here. There is one part. The gas is passed through the porous plug from the high pressure side to the low pressure side. Consider 1 mole of the gas. Here I have taken 1 mole of gas. Let P1 and V1 and P2 V2 represents P1 V1, P2 V2 represents the pressure and volume of the two sides of the porous plug. Let X1 and X2 be the distance through which each piston moves to the right. Each piston moves towards the right. In this case, the external work done on the gas by left piston, which is shown in figure A, this one. The external work done will be W1 equals P1 into AX1, that is pressure into area into displacement. Here area into displacement is nothing but volume, hence P1 V1. This is work done on the gas by left side piston. Let it be equation 1. Similarly, the external work done by the escaping gas on the right side piston, that is second diagram, that is figure A, that implies the work done W2, that is the work done by the escaping gas, that is P2 into AX2, area into displacement towards right side. Area into displacement is nothing but volume, that is V2, that is P2 V2 is the work done by the escaping gas. Let it be equation 2. Therefore, the net external work done by the gas in passing through the plug is delta W equals, this is net external work done, that is W2 minus W1, the difference of these two work done. That is W2 is P2 V2 minus W1 is P1 V1. Let it be equation 3. As the cylinder is thermally insulated, no heat is exchanged between the gas and its surroundings, then the internal energy will be equals 0, that is constant. Equation 4. Then the change in internal energy is delta U equals U2 minus U1. This is change in internal energy of the gas. Let it be equation 5. According to first law of thermodynamics, we know that the internal energy delta Q equals delta U plus delta W. That is internal energy plus amount of work done, that gives the total energy, that is equation 6. As delta Q equals 0, which is equal to delta U plus delta W. Delta U means U2 minus U1. Delta W means work done P2 V2 minus P1 V1. Let it be equation 7. On interchanging, here when rearranging this equation, we get U1 plus V1, U1 plus P1 V1 equals U2 plus of P2 V2. Let it be equation 8. H1 equals H2, that is equal to constant. Here H1 and H2 are known as enthalpy. Here H1 is, here RHS of the equation, that is written as H1 enthalpy U1 plus of P1 V1, that will be equation 9. If P2 V2 greater than P1 V1, if P2 V2 greater than P1 V1, then the internal energy U2 is less than U1. If P2 V2 greater than P1 V1, then the internal energy U2 is less than U1. That means the internal energy will be decreases, and hence we got cooling result. That means boils below the boils temperature, the net work done must be either positive or 0. Net work done is either positive or 0. The same way, if P2 V2 less than P1 V1, just interchange the symbol. P2 V2 is less than P1 V1, then U2 is greater than U1. That means the internal energy will increases, and hence heating will results. That is above the boils temperature. It indicates above the boil temperature the net work done is less. If P2 V2 equals P1 V1, then both the internal energies are equal. U2 equals U1. The gas is perfect and obeys Boyle's law. Gas is ideal gas, hence it obeys Boyle's law. Let us see the regenerative cooling. What do you mean by regenerative cooling? In case of hydrogen and helium, heating was observed at room temperature because it was at a temperature far higher than its temperature of inversion. The temperature of inversion for hydrogen is nearly minus 80 degrees Celsius and for helium is minus 258 degrees Celsius. If helium is passed through the porous plug at temperature lower than minus 285 degrees Celsius, it will also show cooling effect. It means any gas below its temperature of inversion shows a cooling effect when it is passed through the porous plug or a throttle valve. This is called regenerative cooling or Joule Kelvin cooling. This principle is used in the liquefaction of the so-called permanent gases like nitrogen, oxygen, hydrogen and helium. This is about regenerative cooling. This is about the porous plug experiment. Thank you.